Hi, welcome back to the Biognosis YouTube channel. My name is Fabia and I work in the product support team. In this video, I will show you what's new in SpectroMine 3. SpectroMine 3 features exciting major improvements, including a significantly faster Pulsar, our database search engine, full support for the latest labeling technologies such as Turbo TMT and TMT Pro 18, improved support for fractionation, immunopeptidomics workflows, and PTM analysis. In this video, I will specifically focus on the Ptm workflow and fraction summarization. However, if you need more generic information on how to set up an ILQ analysis in SpectroMine, I suggest that you watch our previous video tutorial here. For this demo, we chose a fractionated phospho-TMT 10-plex dataset to show you the new PTM site collapse calculation, regulation analysis, and support for fractionation. Let's first go to the settings and take a look at the new PTM-related parameters. For a phospho-TMT search in Pulsar, the isobaric labels on lysine and N-terminus are set as fixed modifications, whereas phosphorylation on serine, threonine, and tyrosine is added as a variable modification. Next, in the experiment settings, there is the Ptm Workflow node. Here you find the Ptm localization filter, which enables the Ptm localization probability algorithm for all selected variable modifications. You can also set a minimum probability threshold. Under PTM analysis, you enable modification analysis at the site level. This means that SpectroMine will report quantification of each variable modification from the quantities of the collapse precursors carrying that modification on a specific amino acid residue. The flanking region option specifies the length of the amino acid sequence surrounding the modification site and can be used for motif analysis. The multiplicity setting determines how to deal with multiply modified peptides, and the PTM consolidation how to collapse the precursors for site quantification. Once you enable the PTM options, in the analysis perspective, you obtain a protein sequence plot that also displays the confidently identified PTMs. By clicking on the sequence, you filter the tree in the left panel by the runs and proteins that contain that peptide. If you have an experiment with fractions and wish to summarize them by sample, it is important that you specify this in the experiment overview. The block setup allows you to define which runs belong to a sample. Typically, a block contains runs that correspond to the fractions of a sample. If no fractionation was performed, you should assign each run to its own block. In this experiment, the 4 fractions belong to the same block. If I want to treat them as different samples instead, I first remove the selected block and then reassign each run to a new block. This option will affect the normalization within block, that is, the correction for differently loaded channels, and across blocks, which accounts for different feature intensities. In this perspective, you can browse all the proteins and peptides that have been identified by SpectroMine. You can use the tree on the left side, including the tree filter at the bottom, to navigate. If you are interested in more information about this, please watch the video I referred to earlier. For now, I will only show you the new support for diagnostic peaks in the PSM plot. In the PSM plot, you can get a bird's eye view of all the visual evidence for the identified PSM, including the MS1 and MS2 spectra. As shown here, SpectroMine 3 also looks for any diagnostic peak that is specified in your PTM definition, and if found, it is shown in the PSM plot and present in the report. In the post-analysis perspective, there is a node completely dedicated to PTM analysis. Here you can view the candidates list generated from differential abundance testing. In the table, you can find information about the modification site with a collapse key that shows how the consolidation of modified precursors was performed for the multiply modified ones. For each modification site, you will find the log2 fold change between tested conditions and the corresponding Q value. You can also visualize the candidates in the volcano plot and select those of interest. The modification enrichment plot is dedicated to experiments conducted with an enrichment step. It shows the percentage of identified precursors carrying modifications. Finally, the PTM versus protein fold changes plot shows the protein group log2 ratios plotted against the log2 ratios of the modification sites. This plot helps you identify changes on the modification site level that are independent from changes in protein abundance. On the run overview, you can also find the ILQ-NA ratios plot, which displays the percentage of missing values per channel for each run. This plot can be used to verify that channels were correctly loaded across runs. For instance, if you did not use one channel on purpose, this is a great plot to verify that your experiment worked as intended. Last but not least, under the Summarized Fractions overview, you can find the sparse and complete quantifications in your experiment. If you enable the ILQ missing value imputation in the settings, these two values will be equal. Finally, SpectroMine has several reporting options. Next to the standard run report, you can find the summarized fraction report that allows to combine the quantities of different fractions of a sample, and a dedicated PTM site report. This is a site-level report. Among the PTM specific columns, you can find the PTM quantities across ILQ channels, the multiplicity and the number of collapsed peptide that are used to discriminate between singly and multiply modified peptides and to collapse them separately. If you enjoyed this video tutorial and found it helpful, please give it a thumbs up. You can follow our future video tutorials by subscribing to the Biognosis YouTube channel. And if you have suggestions for future videos, please drop us a comment. Thank you for watching.